Hello everyone, welcome back to Industrial Statistic 1. We will continue our discussion on descriptive statistic, and on this video I will explain on how to calculate the mean or the average, the variance and the standard deviation of data. And we can classify the data that we have into two groups. Number one, when the data are individual data, so that's mean the data is not in the form of a histogram. And then we will also calculate the mean and the variance of data that we already group in the form of histogram. I will start with the individual data. So for the individual data, we need to pay attention to the what if the data is a population, and how if the data is a random sample that we take from a population. So if it is a population, then the notation for the mean or average is this one, mu. That's the notation of the mean. And the capital N, it is the size of the population. And if the data is from a sample, then the symbol for the mean is the X bar. And here, the small n, that is the sample size. And I assume that everyone familiar with the sigma notation. So that means you add all the data that you have in the population and in the sample. And as we can see, so the sigma notation start from 1 till capital N for the population, and for the sample we start from 1 until the small n, which is the size of the sample. And variance is the measure of the variability of the data relative to its means. And the notation for the variance for the population is sigma square, and the notation of the variance for the sample is s square, the small s square. And you can see that the denominator, when you calculate the variance for the sample, it is not n, but it is n minus 1. And the standard deviation, it is just the square root of the variance. So sigma is the square root of sigma square, and the standard deviation of the sample, which is the small s, it is just the square root of s square. And here is the range. The range is the difference between the highest value of data and the lowest value of data. And I think I already explained how to calculate the interquartile range, and that is the third quartile of the data minus the first quartile of the data. This is the formula that we use in order to calculate the mean and the variance of data that we group in the form of a histogram. So the x bar sub I, this is the middle point of the interval in the histogram, and the f sub I, that is the frequency, or it is the number of observation that we have in the ith interval. And the denominator here, it is just the total frequency or the total number of the data. And here, x bar, here we have x bar. This x bar is the average of the data that we calculate using this formula. And x bar sub I, and that is the middle point of the interval that we have in the histogram. And f sub I, that is the frequency, and the denominator is the same as the denominator that we have when we calculate the mean or the average. And when we group the data in the form of a histogram, so the formula to calculate the mean or the average and the formula to calculate the variance for the sample or for the population, they are all the same. And in order to make it clear, I will give you an example, and we will start from calculating the mean or average and the variance for the individual data. Okay, let's see if I can copy this. Okay, I will not do that. I think that is not a good idea. So this is it. So this is the data that we have. So those are individual data. We have not construct a histogram using this data, not yet, but we will let it be like this, and we will calculate the mean or the average and the standard deviation of the data. Now, for the first one, so let's assume that this data is your population. Okay, so population. Okay, and we will calculate the mean and the variance and also the standard deviation. Okay, and remember, for now we assume that this data is the population. So the mean, it is just the average. So by using Excel, you can just type equal and then average, and then you select all the data. So the mean of the observation is 160 or 162.66. Okay, so that's the formula that we use in Excel, but the original formula is this one. You add all the data and then you divide the sum using the total number of the data. So if we do that, so I'm gonna calculate the sum. So sum means I add all the data and then I divide it by how many data that I have. So in Excel, if you want to calculate how many data that you have, you can use count and then you select all the data. Oops, sorry. Oops. This is it. So it is just the same, but I'm sure that it is easier if you just put this formula, average. That will give you the mean of the data. Okay, and then the variance. So in Excel, to calculate variance, you can type VAR. That means variance. So if it is just VAR, so it said that it is an estimate based on a sample. So it is the variance of a sample. But we assume that the data that we have here, it is coming from the population. So we need to choose VARP, which is calculate variance based on the entire population. Okay, so I'm gonna do that, and I'm gonna select all the data. So that's the variance. Okay, by definition, here variance, the standard deviation, it is just the square root of the variance. Remember, the variance of the population is sigma square. So the standard deviation of the population is sigma. So sigma is the square root of the variance. So one thing that I can do, I can just put, I will take the square root of the variance. So square root means to the power of 0.5. So that's the variance of the population. Okay. Or other thing that we can do, I can just calculate STDEV, which means standard deviation. But remember, it is a for population, so you choose STDEVP. So this one, so it means calculate standard deviation based on the entire population. So we select all the data. Okay, so see, it gave the same number. But if we follow this formula, the thing that we can do is we take the difference between individual data, between each data and the mean of the population, and take the square of it and add everything, and then divide the result by the size of the population. And I'm gonna show you how to do that. Okay, so the first thing that I'm gonna do, I'm gonna calculate the difference between each observation and the mean, and then square them. Okay, so this is the first observation minus the mean. But remember, I will copy everything down, the formula. So in order to make the here the mean still here, I mean, yeah, so you need to put, you need to lock the mean, so when you copy it down, so the yellow thing here will not move down, so you put F4, so that's mean you lock it. Okay, and then you square it. Okay, and enter. Okay, so this means the difference between the square of the difference between the first data and the mean of the population. And according to the formula, we need to do it for every population, for every data in the population, from the first observation till the end observation in the population. So what we need to do, so we just need to copy everything down. Okay, so the next thing that I need to do is to add those numbers together. So I need to add them, so I just need to sum them. Okay, and then according to the formula, I need to divide it by the total number of data that I have. So I have 80 data, but I will not put 80, but I will just count them, and I will log everything. Okay, see, we have we have the exact same data. So this is if we follow the formula that we have. So if you want to calculate the standard deviation, you just need to take the square root of it, or make it to the power of 0.5. So it is exactly the same. Okay. So this is how to calculate the mean and standard deviation for the individual data. Now I will explain a little bit on what is a variance and what is a standard deviation. Okay, so I'm gonna use this slide, I think. Okay, let me see what I have here. Oh, I don't have it here. Okay, this is it. Okay, the variance indicate how far each observation to the average or to the mean. So the longer the distance or the longer the difference between each individual data to the average or to the mean of the population or to the mean of the sample, then the higher the variance of the data. So that's mean you have more variability in your sample or in your population. So so when you have a set of data and the observation that you have in your sample or in your population, they are all the same, then that means your observation have a uniform value of data, then that means that sample or population has no variability. So when it has no variability, then the variance equals zero, and of course the standard deviation will also equal zero. I give you an example. So let's assume that we have uh, let's see, we have 10 observation here, and let's assume that it is your population. So see that everything is 20, so there is no variation, there is no variability. So what is the variance of this set of data? It is zero, right? Because there is no variability. So let's calculate the variance. Sorry, it should be VAR, and assume that it is a population and calculate it. See, zero. Zero means there is no variability. So all 20, everything is uniform. Okay, and of course the standard deviation is also zero. Okay, now let's assume that the first data is not 20, but it is 5. So now you have a standard deviation and the value is uh, 4.5. Now you see that there is only one variation, right? And that variation is this the number 5, the first observation. Now how if we add more variation? So remember it is now uh, 4.5. Now we add more variation to the data. Now let's see, let's assume that the second observation is 15. See that the standard deviation increase and the variance also increase. So previously when it is 20, your variance is 20.25 and your standard deviation is 4.5. Now I change the 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 second data into 15, so your variance increase and your standard deviation increase. Now I add more variation. Let's assume that is the third data is 10. See that the the variance increase and the standard deviation also increase. So the more variation that you have, the more the value of variance and standard deviation, and the more the distance between uh, each data to the mean or to the average of the population, the higher the value of the standard deviation and the variance that you will have in your observation. Okay, now that is when we have when we think that our data is a population. Now how if it is a sample? So now assume that those 80 observation, they are not population but they are sample. So the mean or the average will be the same. So the formula is the same, average, but the variance will be different. see the formula. Okay, so here the variance, remember this, the symbol is also different. So the mean for the population, it is mu, and the mean of the sample is x bar, and the variance of the population is sigma square, and the variance of the sample is small s square, and the standard deviation of the population is sigma, and the standard deviation of the sample is a small s. Okay, so the x bar or the average is the same. Okay, now what is the variance? So we need to calculate the variance, VAR. Remember, you need to use the VAR only or VARS if you have a different version of Microsoft Excel than what I have with me now. So see that estimate variance based on a sample. So we choose that formula and select all the data. See that the value is slightly different, right? Why it is different? Because of with sample you divide it by n-1, but with population you divide everything by capital N. Now if I use this formula, this formula, so it is the same. I need to calculate the difference between each data and its average and square them and then add them together and divide it by n-1. So I need to sum this, all these guys, because they are the differences between the each individual data and the average. So and then I divide it by count the data. I count the data. So I count the data. There are 80 of them, and then -1. Okay, this is it. See, we have the same value. So of course it is easier if you just use the formula of the variance using Microsoft Excel formula. So the standard deviation should be the square root of the variance. So it is different to the standard deviation of the population, or you can use this formula as the DEV only, or as the DEVS if you have a different version of Microsoft Excel than what I have with me now. So you just select the data, and here we have the exact we have the same number. So that is how to calculate the mean and the variance and the standard deviation of individual observations. Now, how if we group our observation using a histogram, and we want to calculate the variance and the mean, the variance and the standard deviation? So okay, let's see what I have here. Okay, this is what we have. So we have, this is the what we call as the distribution table, and this is the table that we use in order to construct a histogram. Now let's go to the formula on how to calculate the mean of the data that we group into a histogram. So it is just x bar sub I. X bar sub I means the middle point of the ith interval, and you calculate it and you and then you multiply it using the frequency of that interval, and then you add them together, and then you divide it, and then you divide the result using the total number of the frequency. So I think the first thing that I need to do, I need to calculate x bar uh, sub I. So x bar sub I means this is the middle point of the first interval. See, I is the interval. So I equal 1, this is interval number 1. So this is the interval number 1, 75 less than x less than or equal 97. So we just calculate the middle point of it. So it is just the lower bound plus the upper bound divided by 2. Or it is just the average of the two. And then you copy and paste everything. Okay. And after that, you need to calculate the total frequency. You just sum it. Sum. Okay. And it is 80. And then you also need, and the next thing that you need to do is you multiply the middle point of the interval with the frequency of that interval. So this should be x bar I times small fi. Sorry. Okay. So x bar I times small fi. So this is the small fi. So this means the frequency of the first interval is 3. So you just type 258, that is 3 times 86, and then you copy everything down, and then according to the formula you need to add them together. So I just gonna sum them. Okay, and the mean or the x bar or the average is just the total of the middle point times the frequency divided by the total frequency. So that's the mean, 161.625. Now the variance. See, so in order to calculate the variance, we need to calculate the difference between the middle point and the mean that we have calculated, and then square them, and then multiply each of it with the frequency of that particular interval, and then you divide it with the total number of the frequency that we have in your table. Okay, so we need x bar sub I, okay, minus x bar, okay, and then square it. Okay, this is the x bar sub I. Okay, what is x bar sub I? This is x bar sub I, open parenthesis, x bar sub I minus the mean. This is the mean, but remember you need to lock it because you will copy it down, and then you square it, and then you just need to copy and paste. Okay, and what else that we need to do? We need to times it with the frequency of the interval. So this is it. Okay, and then you times everything with f sub I. Okay, so this one times f sub I, or the small f. Okay, and then you sum everything. So because here I have a sum formula, and then I will just copy and paste the formula, and it will give me the sum of this column. Okay, and then the variance, it is just this one divided by the total frequency. This is the variance, and the standard deviation, or the small s, if we think that it is a sample, then it is just the variance to the power of 0.5. Okay, now here there is an alternative formula to calculate the variance. So this is the other way to calculate the variance. So it is the middle point, you square it, and then you multiply it using the frequency of the interval, and then divide it with the total frequency, and then subtract uh, from it the square of the average or the mean. So we will use this formula and see what happened. We should get the same number. So middle point, square it, and times the frequency. So it should be x bar I square times the frequency. Okay. So x bar sub I square it times the frequency, small f. Okay, that's what we need. And then you sum it, so that means we add them together. Okay, and then the variance will be the sum divided by the total frequency, and then minus x bar square. X bar square is the mean that you square. See that we get the same exact number, and of course the standard deviation, or the small s, is this one to the power of 0.5. Okay, and this is how we calculate the mean, the variance, and the standard deviation of data that we group in the form of a histogram. Okay, one last thing that I'm gonna do. So here in my slide, let me see, where is it? Okay, let me see. Okay, here we have a set of data, and the following data present the number of surface finish defect. It is defects. So we can have 0 defect, 1 defect, 2 defect, 3 defect, 4 defects, and so on and so forth. So for sure, this is counting data. This is not a continuous data. Now the thing that I'm gonna do, I'm gonna construct a histogram for this counting data, right? And then I'm gonna calculate the mean and the variance of this data. So I'm gonna calculate the mean and the variance of the counting data that we group into a histogram. Okay, here are the data. Okay, we have how many of them? We have 50 of them. Okay, and see, the first thing that I need to do, if I have data like this, so it is what? It is the number of defect. So first product we have 6 defect, second product we have 1 defect, third product we have 5 defect, and for the product number 50 we have 12 defects. So the number of defect must be 0, 1, 2, 3, 4. You cannot have -1 defect, -2 defect. You cannot have 2.5 defect. No. So it is a counting data. So we're gonna construct a histogram for this kind of data. So the first thing that we need to do, I need to know the minimum value. So mean, so 0. So that's the minimum value. 0, that means there is no defect. And what is the maximum value? So max. So the maximum value is 12. So if the data is like this, so the thing that we need to do is we start from the what we call as the defect. That's the no, the number of defect. So number of defect. Okay, so the minimum number of defect is 0 until 12. So 0 plus 1, copy down, so 9, so 12. Okay, and then we need to calculate the frequency, or the small f. Okay, so if it is so with the frequency, we need to know how many zero that we have here in our observation. So that's the frequency of 0, and how many one defect that we have in our observation. Okay, so here, how many 0 that we have? 1. Okay, so we have 1 over here. How many 1 that we have? 1, 2, 3, and so on and so forth. But with Microsoft Excel, we can calculate it very easy by using the formula of count if. So with count if, you need the first thing that you need to do, you need to put the range. This is the range, and you need to log the range because you're gonna copy everything down. And what is the criteria? So we need to know how many 0 that we have. So just pick the cell that give you the 0 value. Okay, and then enter. So we have 1 0, and then copy everything down. Okay, and then total everything, sum them. See, 50. So we are good because how many data that we have here? Count 50. So we are good. So this is the total. Okay, and how the histogram looks like? The histogram gonna be like just a bar chart. So if you want to get the histogram, so it should be select the bar chart and then select the data, then you add the value. Okay, and then okay, and then you select the value for the horizontal axis, and that should be the number of defect. And this is it, the histogram for the number of defect. Now we want to calculate the mean and the variance. What is the mean? So the first thing that you need to do, if the data like this, so you just need to calculate. You need to multiply 0 with 1. So the variable with the frequency. So the variable here is the number of defects. So number of defects times the frequency. Okay, so 0 times 1, so that's 0, and then you copy everything down. Okay, and then you calculate the total, you sum. Okay, and what is the average or the mean of it? It is just 198. So that is the total of the variables times of that frequency, the number of defects times of the frequency. You add them together, and this is it. 198 divided by the total frequency. So you divide it by 50. So this is the average amount of defect. So this is 3.96. So it is about 4. So that's the average number of defect is around 4. So but even if the data is accounting data, so it is okay to have decimal in your mean or in your standard deviation. Okay, now we're gonna calculate the variance of the number of defect. The variance, I'm gonna coming back to this formula. So we need, I'm gonna use the alternative formula. So we need to calculate the middle point of the interval. So here we don't have interval, we have a point. So we have 0, 1, 2, 3, 4, 5. So what is the middle point of 0? It is 0. What is the middle point of 1? Of course it is 1. What is the middle point of 12? Of course it is 12. So it is itself. Okay, So we need to square the number of defect and then times it by the frequency. So it should be uh, x bar I times frequency, or f sub I. So okay, okay, I will put f sub I over here. So x bar I, you square this guy, so you square it times that small f. Okay, and then you sum everything. Okay, so here you have the uh, numerator, and then we already have the total frequency, so the variance will be 994 divided by the total frequency minus the square of the mean. So that is the variance of the number of defect. And what is the standard deviation? Standard deviation will be the square root of the variance. So is around 2, the standard deviation of the number of defect. And I think this is it, and this will end our discussion on descriptive statistic. Thank you very much.